to the second chapter to get an idea about the structural design. See, the previous lecture was to give an overview of the handbook. What are the different aspects of the precast industry? Now I am moving on to specifically to the structural design. Before you jump into a analysis, you have to understand what is the system. And again, system means it is how the members are connected, how they participate to transfer the load to the ground. This is what this chapter is about. Overview of precast building systems. Similarly, one can talk about bridge systems. Okay. First, I'll be talking about building as a whole for gravity loads. Then, what are the special features required for lateral load resistance? And then, specifically for the roof and the floors. Once I have gone through the systems, then I will be talking about the different components. That there are different options possible. Once I am aware of the options, then only I can select appropriately. I'll be talking about beams and columns, roof and floor units, wall units, foundation units, and miscellaneous applications. Broadly, the precast buildings have two types of structural systems. First is the frame system, or sometimes it is called the skeleton system. And the second is the panel system or the wall system. There is a third system which is now becoming very popular now, especially with the group called Home Mission, which is called the 3D cell or box type construction. Now, I am not very knowledgeable in this, that's why I will not be able to speak much about it, but there are persons even in Pune. I know Shabir Lokhandwala, he is doing this type of construction. And Mr. S.J. Vijay, they are doing this volumetric construction. The hollow block system, which in US is called concrete masonry units, this we haven't covered in the handbook because although they are made up of precast concrete blocks, but it actually falls under masonry construction. But that is also developing, that how the concrete masonry units can be used for at least a few storied buildings. Today I will be broadly covering this one, the skeletal system and the wall panel system. The skeletal system can again be further classified for low-rise portals and frames, which are mostly for industrial buildings, or multi-storied buildings, which are more for residential buildings or commercial buildings. There is a third system which is not adopted in our country that much. I am not very familiar with it. It has been adopted or not, which is similar to the flat slab system. Here, the slabs are cast in the ground, they're lifted up by jacks, and then they're supported on columns. That is called lift slab system. Slab column system, and then we have to put shear walls for the lateral load resistance. But these are the two which are common in our country. Now, when do we go for frame system? This information is actually for the architects. They need to understand which type of technology can be used for what functionality. The frame system is good for buildings that requires flexibility in use and remodeling in the future. What is happening in India is, within 10 years, the tests change. Companies want to refurbish, or the lease period is over, some other companies coming in. And the more high rises we are seeing, more refurbishments will be required. In a frame system, that flexibility is there. You can refurbish, okay. Possibility of large column-free space, less visual obstruction due to walls, relatively independent of MEP systems. That means today you were able to place this. There was no obstruction. Nice ceiling, you were able to place this. Had there been walls, it would have been difficult. Individual units are suitable for production, transportation, and erection. Relatively less weight and hence easy to carry. However, a frame system itself doesn't have much of lateral load resistance. You need supplemental lateral load resistance, and that's where we go for what is called dual system. This is the school buildings which were done by Larsen and Toubro. Very rapid construction, low-rise portals, and these are the industrial buildings. Okay, precast columns, precast rafters, purlins, over that some roofing elements. Now in the industrial buildings, lot of applications are possible: heavy engineering, chemical, railway yards. Okay, and as I said that I have limited myself only to Indian construction because I did not pick up photos from internet. These photographs I got directly from Dr. A. Ramakrishna, who sat next to me, explained to me what to write in the chapter, and then I was able to write this chapter. Yes.
So typically, when you have long industrial structures, steel is preferred, especially for truss systems. In this case, is there any specific reason like fire resistance, or what are the factors that...
See, the choice also depends on the time. These buildings were built way back in the 70s and 80s. At that time, lightweight steel was not there yet. Now, this question is true that with the lightweight steel coming into popularity more and more, yes, they are a competitive material. Whether you select precast concrete or whether lightweight steel, it's a choice. Okay. This can be used in commercial buildings, wholesale outlets, departmental stores, convention and communication centers, airport terminals. This is from the Bangalore International Terminal. Here you can see nice shell elements with the daylight scheme. These are all precast. Okay. Storage facilities, horizontal silos. These are A-frames. I will be talking about them again later. Over that, trussed purlins to make them stiff. Over that, some roofing elements. And there is daylight provisions. You can see a similar plant.
So the right side is also precast. It looks like steel.
No, these are precast. Looks like a timber, right? No, they're precast concrete. Maybe some color they have deliberately, maybe, I don't know. Timber will not last in this type of environment. Coming to multi-story buildings, which is possible in institutional buildings, commercial buildings, parking structures, stadiums. This is the Chennai Silks showroom. Actually, the Timage Precast is the construction wing of Chennai Silks. They have their factory in a place called Tirupur, very close to Coimbatore. And from there, Satya Silan will be coming. These are other buildings. I got this from the Pradhan Mantri Awas Yojana, Urban, PMAY. They have undertaken a project called Lighthouse Projects. Means to demonstrate fast-track construction with different construction methodologies and different types of products. They deliberately wanted to have different schemes in different projects to show the possibilities. There were, out of the 6 lighthouse projects, 2 were with precast concrete. One was the conventional beam and column system, which was done by BJ Shirke in Chennai. Another one was the 3D construction, which was done by Magic Grid in Ranchi. Now, here you can see that I have just picked up some from their brochure. This is the lighthouse project in Chennai. The different stages, and this is a patented connection which is done by BJ Shirke Group, that how they use the concrete as a shell, precast concrete as a shell, within which in the connection region they have cast in place concrete to develop the integrity. They have done substantial tests with the help of CBRI and also with MNIT Jaipur to prove that this particular type of connection is good enough for the seismic resistance. Now this is another set of construction by this Precast India. This photograph I had shown earlier, that how they're erecting the beams and columns, and then they're making this emulative connection. This is a World Trade Center in Pune. This project I had the opportunity to visit. Here they are using their patented connection. As I said, that it is like a bolted connection, which is like a latching type of system. This is an extra data center in Pune. These are the type of members that they are using. Parking garages. This particular project was covered as one of the case studies in the handbook. This particular project on the right side was done by Larsen and Toubro in a very rapid, fast-track project. This was before the 1993 South Asian Federation Games. Chief Minister Jayalalitha wanted this stadium to be done in a very fast mode construction. And the only way it was possible was through precast concrete. And here you can see this stadium is very unique. If you go to Chennai Central Station, this Jawaharlal Nehru Stadium is just within walking distance. I have taken my students for a field trip. And the nice thing of a stadium is that these are all exposed structures. You can see the connections. Unlike in a building which will be covered by facade, you don't see what is inside. Whereas this building is very nice to study how the precast members have been placed. Now those are the frame members made by beams and columns. Next comes the wall system. The wall system are suitable for buildings that require close partitioning of space. This is just the opposite. Earlier we said large column free space, but now I am saying that we need closed spaces. Where is it? It is like residences, hostels. Okay, that's why this is more suitable. We have smooth surface ready to paint or paste wallpaper. Can accommodate insulated panels for thermal comfort. And since there are lots of walls, although it is costly in terms of since the walls are made up of cement, it is costly. Even the 3D construction, these are costly affairs. But we try to gain in terms of the time. Material wise it is costly. Okay. Wait. They of course need tie reinforcement for integration. You can't just stack them, you have to integrate them properly. And they have limited flexibility depending upon non-load bearing wall panels. So the wall panels, all of them need not be load bearing. There can be some wall panels which are non-load bearing. That means today if I have to partition this room into 2 auditoriums, I will place a wall which I can knock off if I don't need. That flexibility can be brought in at the a priori by the architect. This project I had the opportunity to visit. This is in a place called Bhoivara in Mumbai. The Mumbai Slum Clearance Board adopted this wall type system. They made 5 towers. Now, these wall systems are used it can be used for low-rise bungalows also, but in our country it is being used for mid to high-rise apartment buildings, dormitories, hotels. This is the project I visited in Sri City. As I said, the superstructure was built in 2 weeks. This is another building, the SRM University in Trichy. This is also a well-known company, VME Precast. This is a mock-up building which has been done in IIT also. We are going for precast technology. Now, since we are a government institution, we have to have a proven technology. We cannot just go something and a target life is at least 50 years. Our senior faculty, Professor Ravindra Gettu, wanted a durability test done. That's why the first did a mock-up building. We are now having a center called TLC2. lean construction, okay, and low carbon technologies for low carbon and lean construction. Now, this is the way they are building it. They have tested this building by those, what is called water spray and all that stuff. And then just recently this building has been completed. I just wanted to mention that in IIT also we are trying to demonstrate technologies. If it doesn't work out, it's okay. I mean, because it's a small scale. 3D printed, also we are having now, we have a 3D printed house. Even in CBRI, you have the technology park where they demonstrated, okay. In my last visit, I saw the 3D printed facilities they have put up to make a mock-up building. That means this type of technologies can be tried initially and then you can go for a larger scale. The 3D volumetric system or the box system that is suitable for enclosed spaces can accommodate fittings, finishes before installation. It is like a ready-made housing. It has come from Singapore. The Home Mission SJ Vijay was working in Singapore, brought the technology to our country, tried to adopt it for our Indian context. It's a finished product. I mean, sometimes even the toilet facilities also come with that pod. Okay. They provide adequate lateral strength. Of course, they need tie reinforcement for integration and limited flexibility. Here you cannot knock off walls. It's an integrated structure. They can be used in hotels, studio-type apartments or justice facilities, or as a subsystem within a frame system. Like you can have the bathroom or the toilet pods, kitchens, balconies as 3D pods and inserted within the building. This is from the Magicrit construction. This is another lighthouse project which was done under this PMAY. And you can see how they have made this pod structures and they have made this building. That means if you look into the genesis of precast concrete, it started when we had the Hindustan Prefab Limited. These were only components, sunshades, something like that. Then it went to large members, beams, columns, two-dimensional walls. Now it has gone to 3 dimensions. Okay. This is I borrowed from this Home Mission. Mr. Vijay is an excellent speaker. He is about 75 years old, but he is having twice the energy of me. That's the way he can speak. Okay. And he can actually market his product. And this is the way they are building very rapid construction for mass housing. Hollow block system, the concrete masonry unit. Again, it is being promoted in India. In US, you have the full concrete masonry unit association where they have the publications for the building design. They can be used for low to mid-rise buildings, commercial or residential, suitable for vertical load. They can be designed for lateral load. Of course, they need reinforcement to be placed in these spaces. As I said that we did not cover this because this is mostly covered under the masonry system. Our Professor Arun Menon actually is working on this. Okay, this is the overall gravity system. What did we study? That in order to transfer the gravity load, we can have a frame, or we can have walls, or we can have a mix of both, or we can have like a complete 3-dimensional system. Next comes lateral load resistance. That in each one of these, I need to understand how to integrate these members. Let's see the simpler cases. Low-rise portals. I showed you some figures earlier that these columns are acting like vertical cantilevers. The beams that are resting, these are like pinned ends. Hence, I do not have a portal action here. These are just like vertical cantilevers which are supporting the roof. Hence, I need a pocket, or sometimes these are called socket foundation. That means this system, what does it consist of? First, like this is a beam which is resting on columns with corbels, and then the columns are resting on these pocket foundations. Over these beams, we have the purlins, and then we have the slab units. That means we have to understand the different components. Where is the lateral load resistance coming? The lateral load resistance is coming from this fixity of the base of the column. These are suitable up to maybe 3-storied buildings. Beam to column connections are assumed to be pin jointed. They are subjected to sway under lateral loads. The diaphragm action is provided at the roof level. That means at the roof, we are trying to make sure that all these columns should act together. Hence, over the roofing elements, there should be some structural topping. The other system, this is what I showed in the figure, A-frames. These A-frames are actually gable frames, which are moment resisting. Here, I do not need pocket foundation. This is a simple pad foundation. The beam and the rafter, they are having an integrated connection. However, in order to make this frame, now we are trying to break it at the points of inflection under gravity loads. This top piece is made separately and the bottom piece is made separately. That means the component is A-frame top piece, 2 is the bottom piece, this is the pad foundation, and the rest are similar. These are sub-assemblages of rigid beam to column joints. That means when I am casting it as a sub-assemblage, not individual ones. Connections are coming at the locations of zero moment under gravity load. Foundation simple pad footing is okay. Now, whenever I am going for multi-storied buildings, again, of course, now the demand is increasing, the earthquake forces. How do I generate the lateral load resistance? In a frame, we know the basic requirement is the rigidity of the beam column joints. And that's where we are targeting that the beam at the column junction be made with wet concrete. And this is the technology which BG Shirke or Precast India Infra, they are going with. So they are saying that this is what we are familiar with in India, and we will go by this. That means it's a mix of precast and cast in place concrete, which gives this emulative type of connection. Another possibility of this is that you cast it as sub-assemblages and integrate them at the points of inflection. These are suitable for mid to high-rise buildings, needs on-site concreting, and what type of sub-assemblages you cast, it depends upon your choice. Whereas in US, they are going for what is called dry jointed connections. Means now, these beams are sitting on corbels and they are having some integrity through some reinforcements, or they are having post-tensioning ducts. That means in a corbel, the problem is that you are having this extension in your formwork. Sometimes architects don't like that. Okay. Whereas on the right side, we don't have these corbels. These frames, of course, they need lateral load resistance, which comes from shear walls. And we can have the option of self-centering system using pre-stressed tendons. The dual system means we are trying to match the functionality requirement of large column free space with the structural requirement of lateral load resistance. In the core, we have this wall system which provides the lateral load resistance, whereas outside we have the frame system which is giving the column free space for functionality. This is the traditional way the tall buildings in US were designed. Okay, that core in the middle, column free space all around. When it comes to the wall system, the lateral load resistance is typically satisfied. The problem is how to keep the flexibility. That's where comes that we can have what is called non-load bearing partition walls to generate partitioning so that they can be knocked off in case if it is required in the future. This wall system consists of load bearing exterior or interior walls. There can be load bearing spine walls in the longitudinal directions and non-load bearing cross partition walls. That means this is one particular scheme which is possible. Now coming to the roof and floor systems. Shall we take a break now?
I think we can take a break.
See, what did we study in the systems was overall system. Overall system means we have to cater for the gravity loads for every second of the life of the building. First, we have to think about it. Then, if you're designing a building for lateral loads, and here I primarily mentioned earthquake, then we have to think of the lateral load resisting features. Okay. Now I am talking of a subsystem within the overall building system. Subsystem is the roof or the floors. What is the difference between roof and the floors? Floors have to be flat for usable. Roof need not be. Whatever floor systems we are studying, that can be used in roof, but whatever roofs we are studying, that may not be used in floors. For the roofs, we can have slab units with additional topping, and these units are supported by purlins. It's very much similar to steel construction, steel shades, which are supported by trusses or arches. We can also have shell units, and we can have folded plate units. One photograph I have shown for our ocean engineering wave basin, where they have used folded plates. Now let's try to understand these buildings which we have seen earlier. This is a school building. Here they have made, these are like vertical columns with pocket connection. Over that they have placed some rafter. Over that there are certain purlins running in the longitudinal direction of the building and some slabs. That's it, simple construction. Okay. Here you can see, this is a zoomed in view of the roof. These are trussed purlins. Why trussed? To make them more stiff. And over the purlins, they have placed roofing material. Some of them are transparent. Here you can see how nicely an industrial buildings can be made. These are ribbed slab units. Why ribbed? Again, these are like stiffeners. The span is increasing, hence these ribbed slab units can be even pre-stressed. Okay, like pre-tension, precast pre-tension. These ribbed slab units are supported on trusses. These are then supported on columns. This is another option. These are the shell units. Here you can see again a silo structure, how elegantly it can be made. These are the arch units, precast. Over that, these are the slab units, which is making the roofing element. This is the zoomed in view of the Bengaluru airport, where these are the shell units and these are the daylight provision. Folded plates, again these are all in, this is industrial structure. A folded plate roof, and this is a laboratory structure where also they have used, these are diamond stiffeners of the folded plate. Coming to the shelf is a topic by itself. At one point of time, if you think, there were so, famous shell designers. Okay. Shell, as I said, is a matter of imagination and how to construct. There can be a full lecture on beautiful shell constructions, and most of them were aesthetically very pleasant. This is a roof over the Structural Engineering Research Center. Again, these were precast, that means they were cast in the ground and then they were lifted up. This photograph, it may not be so clear, but these are like, the shape is like an inverted, like a tent structure. That's the way our Student Activities Center, a long span roof was made. Coming to the floors, again we can study the floors in two ways. The way we study slab design in undergraduate. One is two-way slabs, which are with emulative connection, or it can be one-way precast slabs spanning between beams. The components of floors made of one-way units are precast units. What are the spandrels? Spandrels means which are the supporting members at the edge. Spandrel members may have to be designed for torsion also. There can be some intermediate beams, and some special type of reinforcement is required to integrate the precast unit to generate the diaphragm action. This I had mentioned earlier about the diaphragm action. I will be speaking about that now. This is a schematic sketch of what are the reinforcements required for a diaphragm action. The diaphragm action is required more when the aspect ratio in plan, the length to width ratio becomes large. This slab in plane, it is trying to bow out. And in order to stiffen, we need to provide reinforcement at the edges, two edges. These reinforcements are called chord reinforcement. In an Indian construction, after we place the precast planks, we will be placing the reinforcement and then we will be having a structural topping. Whereas elsewhere, what you may see is that within this precast planks, there is a groove has been placed where you put reinforcement and then you just put some topping and flush it. Now, these individual members either can be stitched, which is done abroad, that we stitch by welding the steel embeds that are there in the planks. In our country, we do not stitch them. We provide a conventional structural topping throughout. That gives a complete integrity. And we can say that that is like a composite slab. That means the precast slabs are being designed for the gravity loads, whereas the structural topping is being designed for the diaphragm action. Okay. If there are shear walls, then we have to connect this diaphragm with the shear walls because we need to mobilize the shear walls, and that type of anchorage is necessary. Again, there are connection details between these walls and the slabs. Okay, with this, I'm just having this overview of the roof and floor systems. Now let's come to the components. Components, if I'm looking into there can be different types of sections depending upon the applications. And this I picked up just from my advisor's class notes. These are drawn schematically. In reality, you may find a bit more details. Thus, rectangular cross sections are suitable for small members like roof purlins. Whereas if the member size becomes bigger, we tend to go a bit tapered section. The reason is for the release of the formwork. That is better. If the span increases further, then this becomes inefficient. And then we go for these flange sections that we have learned in our third year civil engineering. And it can be a single flange or it can be a double flange at the top and bottom. And as I said that these sections will not actually look like this, it will look like a bulb where you can be having pre-stressing strands. And for bridge girders, this is the type of section which is adopted. Other types of sections are beams with ledges. If I am trying to support hollow core slabs over beams, then I will be having this type of ledges on one side or on both the sides. This is a spandrel beam, means slabs is coming only from one side. It is subjected to torsion. Whereas this is an intermediate beam where slabs are coming from both the sides. Now this beam is having the ledge at the bottom which is supporting double T girders. Now double T girders are for longer span roofs. In our country they are used for parking garages or industrial structures. Again, this is a spandrel member with ledge on one side. This is an intermediate member with ledges on both the sides. Further variants, you can have somewhat like this, asymmetrical. Today in the morning I said that we are assuming symmetrical, but there can be cases which are asymmetrical. Section with a void, this is for passing the air conditioning ducts. Or trough girders. This is for roof, where to have proper drainage. Or somewhat, this is just a variant of this. Okay. In bridge, the bigger form of this is called the box girder. Coming to columns, different options are possible. How to support the beams. This is the common type, which is having a corbel. We teach corbel design in our course. Or it can be a stepped column. In steel, this is very much adopted. That means you have one size here, another size over there. In concrete also, we can go for a stepped column. Or we can have a steel insert. This is for the mechanical type of connection. We are having a steel insert within a column. Or a column with a shape which can support a gutter. A column which is supporting a spandrel member. Or other variants of columns are also possible. Now let's see some figures. These are the figures I took when I went to the Timage factory. Here you can see the double ledge. These are the shear reinforcement for the connectors. These are the columns, okay, which goes to the pad foundation. They were making their own factory by their own products. We can see that these are the products line, they're raising it up and they're extending their factory. This is a trough girder. That means this is like for the gutter space, you keep it slightly inclined and that's the way you can have the roof drainage. Now this is a very special type of construction. This is for a textile mill where the humidity and temperature control were the prime requirements. They provide the duct inside the beam and you can see these holes which are actually for the air conditioning air. Okay. And please note that this voided girder is supported by Y columns. Coming to the roof units, what are the components of a roof? The slabs, these are supported by purlins, supported by girders, supported by trusses or arches, or shell units or folded plate units. That means whenever you are going to analyze a design, you have to understand this load path. From the top, how the load is getting transmitted to the ground. If I look into roof girders, these are the saddle type of members to have just drainage, or you can have a camber. This photograph I had shown in the morning, that these are the pre-tensioned, the bottom cord is pre-tensioned. You're making the trusses, lifting it up. Over that, you are putting the purlins and the slab elements. This is the Kantirava Stadium, which was it was championed by Mr. Sundaram, and these are all individual shell units which are placed together. This is the shell units, hyperbolic paraboloidal shells in Sai Bhakta Nivas in Puttaparthi. Now here you can see how nicely this shape has been given. This is another folded plate type of roof unit. Now in the handbook, this is the information which was compiled by Larsen and Toubro. Thanks to Mr. Ramakrishna who gave this to me, and we have documented this in the handbook for future use. That which type of truss was suitable for what type of span, for what type of loading. These are all the case studies. Spans, for what purpose it was made, span to height ratio, some information is given. Coming to the floor units, this is a schematic sketch. The hollow core slabs, right now this has become quite common in our country. I think Professor Suryas will be speaking about that. Biaxial hollow slabs, this is also coming. Biaxial hollow slabs is an extension of the concept of reducing weight by having voids, but these slabs are bending in two directions. The hollow core slabs is only one direction member, whereas this is bends in two directions. You have a precast bottom, over that you place a steel mesh, Then you place some plastic balls and then you cast the concrete. This is the ribbed slab which I showed before. A larger version of ribbed slab is the double T girder. Waffle slabs are also possible, precast. And then composite slabs. Composite slabs means you have this is called a filigree element. Filigree means the bottom piece. Over that there are some steel trusses which are actually inserted to lift them. They are brought from the factory. And then these steel trusses also act as shear connectors with the concrete that will be cast. This is the photo. If you, I believe the factory visit that we are going to have, we shall see the manufacturing of this. This photograph I have shown that how they are using two-way slabs. This is another project in our campus which used this hollow core slabs for an indoor sports complex. Now here the demand was there are badminton courts, and since there will be like jumping around, the frequency has to be very high. The members have to be stiff. That means the thickness of the slabs were not determined by a deflection. They were more determined by the stiffness criteria. Okay, that during the playing, they should not feel the vibration. This photograph I have shown earlier that how they do the connection. This is the another photograph of the slab using ribbed slabs. This is with the double T units, Bharat Forge Research and Development Center, Pune, very high-end type of industrial buildings. This is another facility in Pune. Coming to wall units. Wall units can be load-bearing or non-load bearing. Load-bearing means they are carrying the vertical load from the top down, whereas non-load bearing means they are there just for partitioning, which can be removed in case of refurbishment. Spandrel units are at the edge. Facade units, I will show you some photographs that these days the building facade is becoming very important, okay, for the high-end buildings. And then these are special type insulated panels which are used for cold storage places. Textured panels. This is a image factory that this is the type of units they used in the Sri City hostel building. The walls are having a brackets to support the slabs. This is the window opening, and you can see how they are manufacturing it. This is how they are lowering the slabs through the dowels. They have a complete RFID, the radio frequency ID system, to keep track of all these elements. These are some elements, these are old constructions from the Jamshedpur, this residential units. These are the school buildings. Now this is the textured finish. These are, you can see this is called a beer bottle type of finish. This is a corrugated finish. And these are possible only with precast. You cannot have cast in place to do all this. This particular building, the Infosys multi-level car parking in Pune, if you visit Pune, I would say this is a building must see for a student of precast concrete. I was fortunate to go to the factory. This is it is made up of like, these are the spandrel elements, these are the columns, and then they're keeping some brackets. Over the brackets, they're making this honeycomb type of facade elements. And it needed a lot of engineering detail to fix this. This particular building got an award from the European FIB, European Concrete Society. In fact, in one of their handbooks, this is in the cover page. Foundation units, I had shown this in the morning. These are the shallow foundation units for pad foundation or socket foundation. These are the deep foundation units for piles. Miscellaneous applications. service trenches, boundary walls, stairs, grandstand units, sitting units in auditoriums, supporting components in industrial structures. All these are part of different types of buildings. Let's see some examples. These are the electrical trench units. These are the boundary wall elements I had shown before. IIT Madras is having an extension campus where the boundary, these are precast elements. Stair units are also common. I'm pretty sure we are going to see this in the factory. In the Kantirava Stadium, even the indoor, lot of precast, application of precast. All the sitting units were made up of precast. This particular stadium in Madurai, they are made up of precast elements. Industrial applications, these are conveyor belt housing. You can see from the interior how nicely it looks, this precast system. These are pipe rack structures which are made up of precast. Again, to end this presentation, we first understood the systems that given an architectural plan, we have to understand how we are going to transfer this load to the ground. What type of system should we adopt? The two common types are the frame system and the wall system. The cellular system or the box system is coming for residential construction. Then in each of these systems there are certain components. Different components are possible in different types of application. We have to understand that, and then only we will be able to go to individual design. Okay, any question? Students? Okay, what I will do next is, see, when we decided this course, I think now you can stop the recording. The formal lecture is over.